Very good evening. Today we are going to discuss linear regression equation, that is simple linear regression equation, where it consists of one dependent variable and one independent variable. And we'll take practically one example to implement this, how it is going to be implemented, that we are going to discuss with the practical example. So basically, linear regression is a statistical technique. It is used to model and analyze the relationship between one dependent variable and one or more independent variables. In today's session, we are limiting ourselves to one dependent variable and one independent variable. So it is also called a predictive model. Any regression model, we use it to call it as a predictive model. The example equation for the simple linear regression is represented as y equal to a plus bx plus epsilon. And b is called the slope and a is called the y-intercept and epsilon is called the error term. So that is the variability in y cannot be explained by the linear relationship with x. So epsilon is the error term, that is variability in y cannot be explained by the linear relationship with x, whereas y is a dependent variable and x is the independent variable. So when we consider more number of independent variables than single, then it is going to be called multiple linear regression, which is going to be discussed in the next video. So before going for taking an example and implement it, I would like to stress upon how do we calculate the slope and y-intercept, that is b and a. For this, we require normal equations. How many unknowns are there? There are two unknowns, b and a. So we need two normal equations for this. And suppose we are considering the linear regression equation as y equal to a plus bx form. Then the normal equations for this is sigma y equal to na plus b times of sigma x and sigma xy equal to a times of sigma x plus b times of sigma x square. Why I am considering sigma? Because the number of data points we are considering into this as n. So that's the reason we are applying the sigma, summation of those points we are considering. And here, solve these two equations. That is, we know sigma y and we know x, sigma xy, sigma x and sigma x square. If you substitute all these values into these two equations, yeah, and n also known. So only we are going to get 2 and 3 equations in the form of a and b equations. So those two can be solved in order to get the values of a and b. Once you know the a and b value, we can submit into the substitute into the equation 1, so that you are going to get a linear regression equation. If you look at, this is the data set I am considering. Heights of few students was given and weights of them was given along with their heights. So 120 centimeters height student is having the weight 50 kilograms and 140 centimeter student height with 70 kilograms weight. Like so, if you look at, there is a height is increasing, weight is also increasing linearly. They are dependent. So if you look at this way, once you plot this linear regression equation, you are going to get like this red line, which is fitting all the points. And this is the slope we got it, and this is the intercept. So if you substitute these two values into that, it is going to become weight equal to 0.7935 of height minus 43, which is the intercept form. Now, we have taken this data, but we converted into a linear form. So once you know this, we can able to manipulate. That means we can able to predict for new students' heights. We can able to calculate. We can able to predict their weights. So I have taken 130 centimeters as height, which is not given here. So for that, the weight was predicted as 59.58 and 145.0, 71.48. Like this, the predicted values are there. All these predicted values also, once again, we plotted onto that. If you look at how exactly it has fitted onto this equation. So here we are taking x as the height and y as the weights of the students. So now, second example I am taking, which is more near to the real time. So sometimes the person is lower height, but weight is more. And sometimes the height is more, weight is less. So these are the cases we are considering: 140 centimeters, 60 kilograms weight, 120, 70. These are the kind of environment when we are considering. Again, I am calculating the B and A. The equation is going to be like this. So this is of the format we are going to have. So the predicted values of 132, 145, and 152, and these are the values. So this is how a different example with the different weights and heights we have considered. So this is how it is going to be represented. Now coming to the plotting of this, you see here I have plotted with these values. So this is how they are not exactly fitted in the real-time scenario. So this is the form we are looking at for a simple linear regression. So exactly to fit, we need to go for higher degree polynomial or some other method we are going to adapt into this. So the example 3 we are considering into this today's topic, linear regression, predicting the exam score. So to predict the student's final exam score based on the number of hours they study. So how many hours you studied, the score is going to directly proportional. So studying means with total effort and total concentration only we are considering. So dependent variable y, the final exam score, independent variable x, the number of hours the student has studied. The objective is to establish a relationship between the number of hours that is studied and the final exam score. So we collected the data and we got the linear regression equation as final exam score equal to 50 plus 5 into hours study. 5 is the slope and 50 is the y-intercept we are considering here. So this is how the third example of today's model we are considering. And the summary is how the linear regression equation is used in predicting the dependent variable or the target variable by considering the independent variable values. So it is a predictive model once again. And thank you one and all. And please do subscribe. Any questions you can please put into the link below. Thank you one and all.